All right, number 3. 2x squared plus 4x plus 1. You have to find the roots or solutions, or however it's worded. You have to find the vertex. You have to find the end behavior. And you have to find the y-intercept.
I know the y-intercept.
What's the y-intercept?
1.
Very good. It's the number without an x on it. Very, very good. What's the end behavior? Who knows that? It's either goalposts or droopy arms.
Oh, goalpost.
That's right. It's positive. This is going to be up, up. Now, A and B are the parts that take a little longer. For the vertex on part B, and I'm going to kind of work backwards on all of these because D and C go the fastest. On part B, the vertex is given by this formula. Hopefully that rings a bell. Negative B over 2A.
How you got to put it in the
Calculate.
one thing, you know?
No.
You ain't got to do that big fraction or whatever?
Oh, that formula over there on the board?
Yeah,
That's for part A to find the roots. Yeah. But right now we're just looking for the vertex. So negative. So A is 2, B is 4, C is 1. I still see people putting X's in their formulas. You don't need any X's once we start working with this stuff. Negative B.
Negative 4 over 2 times 2.
Very good. And what does that reduce to?
Negative 1.
Very nice. Well, we're going to just rock and roll right through this lesson. Now, to find the y value, who remembers what you have to do? Because remember, the vertex is a coordinate. What?
Is this for the beak?
Yeah.
You use that formula, the under the horizon.
That's the discriminant. That comes with part A. To find the y value of the vertex, and if you're wondering what I mean by the vertex, every parabola has some point where the vertex kind of splits and goes off into its, and that point is called the vertex. So you need an entire coordinate for it. Our x value is negative 1. Well, let me ask you this. If you have an equation or a function or whatever, if you have an x value, what's the only thing you have to do to find the y value? Plug it in. Yeah, we're just going to plug negative 1 into the function, which you're welcome to do on your calculator, or you can do by hand. I'm just going to do it by hand real fast. So let me erase some of this stuff and do it by hand. Okay. So, plugging in negative 1, that's 2 times negative 1 squared plus... No, we're still on B. We're looking for the y coordinate because we only have the x right now. Negative 1 squared is just positive 1. 2 times 1 is 2. 4 times negative 1 is negative 4. Well, let's see. 2 minus 4 plus 1. What is that, negative 1? I believe so. That is the coordinate of our vertex.
What is that at the end?
That's a plus 1. It just kind of ran together. And the whole thing equals negative 1. Part A. Part A. All right, part A is the roots. And the roots, who can tell me what the roots are before we even solve for them? What are roots? Or zeros or solutions or whatever. What are they? That's the discriminant. Yes. But but roots are where your parabola is going to cross the axis. That's what we're looking for now. Those accurate points. And to find those, you need that formula over there on the board. The quadratic formula, which we dealt with a week and a half ago. You need the formula negative b plus or minus b squared minus 4ac all over 2. Oh, that's an A. A. 2a.
What does that say?
That says b squared minus 4ac negative b plus or minus. See, this end of this thing is spongy, so anytime I try to write fast, it kind of drags.
Try using one of these calculators.
All right.
Yeah.
How do you get me one?
So, negative b plus or minus b squared minus 4ac all over 2a. Sorry. All over 2a. So, now, If you look in the directions, see how part A says roots, parentheses, and discriminant? That's because when you find the roots, you're also finding the discriminant. The discriminant is just the part under the radical. Who remembers what that tells us? What does that discriminant tell us?
What? Which one?
Just the discriminant. You remember that? We did it last Thursday. Yeah. If it's positive, anybody remember what that means? It was positive, negative, or zero.
There's two of them.
That's right. Positive meant you have two roots, like they actually cross the axis. Negative means you have imaginary roots, which is like your parabola will never cross the axis. And if it's zero, it means you have the same root twice, which means your parabola is, it's just going to like touch the axis at that point. That's what it tells us. Now, what's this going to be? It's going to be 16 minus 8.
Yeah.
Okay, so that's negative 4 plus or minus the square root of 8 over 4. So is it positive, negative, or 0? Just the discriminant. Is it positive, negative, or 0?
Positive.
Positive. So
Wait,
we're going to
what?
have two roots.
What's positive?
The discriminant.
Oh.
Now, which means we're actually going to cross in two places. Now, you're going to have two kinds of questions on your test. One is just going to be like, hey, here's a function, find the answers. And the whole answer to the whole problem is just going to be finding your two roots, in which case you'd have to reduce the radical and all that stuff that we've
I
done.
think that's the hardest part.
I do too. But when you're asked to graph, that's just a detail. The point is, you can't graph a number like this. You need it as a decimal. So today, since we are graphing, I just want you to find this as a decimal. So let's go to our calculators. I think this is going to go away, but hopefully... Does everybody have this written down? Because I have to take this off the screen for a moment. Okay. Calculator. All right. So, negative 4 plus, we'll do plus first, square root of 8. You probably want this whole thing in the parentheses. Negative 4 plus square root of 8, what was it, divided by 4? And one of our roots is negative 0.29. So you might want to write that down, negative 0.29.
On this paper?
Well, that's part A, negative 0.29. But there's two of them. So to get the second one, I just hit second enter. It brings up the same exact equation. What's the only thing that changes? Remember, wasn't it?
Minus.
That's right. It became negative 4 minus. Because wasn't it negative 4 plus or minus the square root of 8 over 4? So now we have to find the minus one. And that is negative 1.7. So negative 0.29 and negative 1.7. Those are our answers to part A. So, real quick, it was negative 0.29, negative 1.7, B was negative 1, negative 1, C was up, up, and D was 1. Now, with all of that, we're not sketching today. Today we're doing exact graphs. I'm looking for exact points. And here we go. You're going to plot all those points and then just connect the dots. First, let's do the vertex, part B. That's the easiest one. Negative 1, negative 1. That's where your parabola is going to start and go upward. Our y-intercept is positive 1 from part D. Oop. Don't know how I did that. Let's see, our roots were negative 0.29, which I'm going to ballpark to be about right there. Negative 0.29. And negative 1.7. Which is approximately right there-ish. It's okay if they're off by like millimeters or whatever, as long as I see the points round about where they're supposed to be. So we've got our roots, we've got our intercept, we've got our vertex, and we know how it breaks. It goes upward, so now just connect the dots. Whoa. There we go. Close enough.
Wait, we have to do that?
Yes. In the directions it says graph accurately. So that shows me that you went through, or at least tried to go to, your points, your y-intercept, your vertex, and your end behavior. And then you can graph that on your calculator and verify that you did it correctly. But you should.
Put all the points out.
The vertex, negative 1, vertex. That's where it breaks. Okay? Your roots, that's where it crosses the x-axis. Negative 0.29, negative 1.7-ish. I wish they had turned out a little prettier, but they didn't. Your y-intercept was positive 1. We plotted that point. And then from here, you know it goes up, up, so start at the vertex and just go through your points. All right.
What's that other dot for? On the very top.
Here, it's the y-intercept. That's where it crosses the y-axis. Questions? All right. No. We're going to go back and do number 1 now, if there's no questions. Well, we can at least get started on number 1. So we need the roots, the vertex, the end behavior. What's the end behavior going to be?
Down.
Very good. What's the y-intercept? This one's a little trickier. That's right. If there is no number without an x, it's just 0.
So y-intercept is 0.
On this particular problem, yes. Now, if you are missing terms, it might help you if you kind of write them in with a 0. Plus 0x. If you are completely missing terms, I would recommend writing them in with zeros. That way when you do your parts A and B, you'll be able to pick out your A, your B, and your C for the formulas. In fact, if you look at number 2, you should notice it looks a lot like number 1. You're going to have to do that in a minute. In fact, if you want to go ahead and write in plus 0x plus 0, I would recommend that. We'll find the vertex and go to lunch, and we'll do the roots when we get... Oh, I say when we find the vertex. No. Then we'll go to lunch. Okay, so what's my... It's negative b over 2a. And don't think... We have to find the y value, too. What's my b value? 0. So that's negative 0 over 2 times negative 2. What's 0 divided by anything?
0.
So we still have to find the y value. So calm down. How do you find the y value? Plug it in. So that's going to be negative 2 times 0 squared, which was the original. What's 0 squared? What's negative 2 times 0?
0.
That's our y value. Lunch. Part A is find the roots, and that's where you need the quadratic formula again. Don't forget it was plus 0x plus 0. For the roots, it's negative b plus or minus all over 2a. Negative b is negative 0 plus or minus 0 squared minus 4 times a times c all over 2a.
Isn't that a negative 2?
Yes, it is. Thank you. Okay, so it's in the discriminant. 0 minus, what's 4 times 2 times 0?
0.
0. So it's 0 minus 0. So I'm out of space, so I'm going to write this at the top. That's going to be 0 plus or minus 0 over negative 4. Now what was our discriminant? What was the number under the radical? 0. What did that mean? I drew it up here before lunch.
One solution.
One solution, it means at one point it's just going to touch. And what was that point? Well, we actually have to find it. 0 plus 0 over 4, 0. 0 minus 0 over 4, 0. So our one solution that occurred twice was 0. Now, this one's almost, it's so simple that it's almost going to be hard in a minute because all of our points are going to be the same point. So, get that down. I'm going to erase starting at the bottom. Hopefully you were keeping up.
That eraser's cool.
You mean how it like fades out? Yeah. All right, ready to graph.
So the answer to A is just 0.
Well, it would technically occurred twice. Nothing. Nothing. So the y-intercept is 0. The x-intercept is 0.
Basically, the entire thing is 0.
The vertex is 0, 0. Well, where is the end behavior?
0.
Down.
Down. So it's just going to break down. Every single critical point we had happened to be 0. The x-intercepts, the y-intercept, the vertex. So the only thing, whoa.
This is sort of interesting.
So the only thing, hold on. There we go. So the only thing we really had to graph was the 0, 0 point and the negative. Questions?
So is A just 0?
Yes.
Don't know.
Well, it's 0 twice technically. Technically, it's twice. And actually, here's why that's important. Shh. Tomorrow, one of the things we're going to be actually, that's not tomorrow. In the future, one of the things we're going to be talking about, we're going to be doing stuff in the future like this. Now, this is just a glimpse, but here's why it's kind of important to know that 0 happens twice. Let's say we had a problem. This is where we're going. You don't have to write this down. Actually, I'll just do that one. Okay. What's going to make just this part equal 0 if I plug it in for x? What could I plug in for x right there that would make that equal 0? 1. Now, isn't x minus 1 cubed, x minus 1, x minus 1, x minus 1? Where we're going with this is, that means 1 is a solution 3 times. And what would make this one equal 0? Negative 2 is a solution 4 times. The reason that's important is, where we're going with this, you're going to find out every time a root occurs an even number of times, that means it just touches the axis instead of crosses. But where it occurs an odd number of times, like the 1s, that's where it's actually going to cross and go through the axis. So that might prove useful here. If by knowing that they're both 0, you should know that it only touches the axis because it occurs an even number of times. That's how that's going to link with something we're going to do in the future. But for today, I guess all you have to know is 0 is the only one. Okay. Last one. Number 5. And I'm going to cut you loose.
Number 5.
Number 5 on the back. A, B, C, and D. What's that? That's right. D is negative 3.
And the behavior's down.
That's right. The end behavior is down, down, because it's negative. So all we have to find is the vertex and the y-intercept. I mean x-intercept. How'd you get that? Good for you. I'm going to give you guys a second to try to come up with the vertex and the x-intercept. So let's see if we get the same thing. Try to find, because this is what you're going to have to do in just a minute anyway. So try to do these now, and then we'll see if you get them right. What's that? Yes, yes it is. So you should be trying to find the vertex and the x-intercept. Oh, except I'm getting positive 1.
You're getting a...
Did you do negative b over 2a?
Now is that what it's supposed to be? Negative B?
That's how we've been doing it, isn't it? Negative b over 2.
Negative B, okay.
Yeah.
I got negative 4.
No, I was just trying to make sure. Well, negative 4 over what? It's negative. Oh, you mean when you plug it back in?
I just plugged in. I just typed in negative 4 over 2 times negative 2.
So
Which
minus
is
negative 1
1.
and positive 1. Negative-
Positive, because it's negative over negative. Negative divided by negative is positive. So when you plug positive 1 in, what do you get? Negative 1? I think that's what I got too. So your vertex would be?
Wait. Don't do the next one.
Okay.
I want to finish this.
Okay. Try to find the x-intercepts. I will not do it, but I will write the formula on the board.
And the Y is negative 1 too, isn't it?
Well, the x was positive. Yeah, the y was negative 1.
I didn't make that.
My calculator said said it's 4.
I'll come look at it. It's probably just an order of operations issue. Let's take a look. Okay, because it's negative b over 2a. Negative b. Oh, okay. See, it's doing it left to right. It's doing 4 divided by 2 times negative 2. But if you put the entire denominator in parentheses, because now it knows to take this divided by the whole thing. See what I'm saying?
Where'd y'all get negative?
Do you get where the positive one came from? So we took the positive one, plugged it into the function, we got negative. Because that's how you find the y value. You plug an x in, you get the y. For all the x's, you plug it for all the
Give me
x's.
a piece. I saw you do it. I call it with
I just don't know how to do this.
Let me guess.
Oh, you reduced it. Only thing, everything's right except 4. So you broke this down into 4 and 2, correct? But it's the square root of 4 and square root of 2. What's the square root of 4? So it would be 2i, right? We only did that last week if, like, remember when we did all the factor trees and everything? If you had 2 2's that you brought out, you would. But no, you would just, it'd be 2 radical 2. Yeah.
What do I do once I get
Where'd your negative go? Shouldn't that be negative? Actually, stay right there for a second because you're. Today, nothing, but I'll show you what to do in the future.
You have to type that in there, don't you?
No? No, you don't. Yeah, and we're going to do it together now. Okay. I'm seeing a lot of good work on papers. That's excellent. So, negative b plus or minus b squared minus 4. Hopefully you remember to make your 2 and 3 negative because they're negative in the problem. Over 2a. Now, that reduces to negative 4 plus or minus 16 minus 24 is negative 8. Now let's stop for a second. If your discriminant is negative, which ours is, what does that mean?
Don't you take that out?
Yeah, put that
1 second. Yes, it does. But before that, remember the discriminant was either positive, negative, or 0. If it was negative, what did that mean?
2.
You go on.
Non-real.
That's right, non-real or imaginary roots. Now, if you are asked to graph, once you've seen their imaginary, that's kind of everything you need to know. It doesn't really matter what imaginary roots they are. If you know they're imaginary, then you know that your graph is never going to touch the axis, which is really all you needed to know. Now, there are going to be 2 kinds of questions where you have this problem in the future. Well, 3 kinds. And you saw 2 of them on Friday. A, it's just going to say, what's the discriminant? What does that mean? So that'd be negative 2 imaginary roots. Part B, you might say, what are the solutions? And you will have to work this out. Reduce the radical, pull out the I, and all that stuff. And I can show you how to do that again. But for graphing, once I know that it's negative and that these are going to be imaginary, that's really all I need to know. So I can just write 2 imaginary roots and know that I won't actually have to graph them because they're not going to exist. Now I'll show you how to reduce that for the future, but for our purposes, you could just write 2 imaginary roots and you know you won't have to graph those.
Yeah, when I'm trying to reduce that, I got 2 minus radical 2 over 2.
Actually, that's really, really close. 8, let me just do that on another page. That's going to be negative 4 plus or minus. Now, 8, well, let's go ahead and pull out the I. The negative is going to come out as an I. Can't 8 break down into square root of 4 times square root of 2? What's the square root of 4? 2. So it'd be negative 4 plus or minus 2i radical 2. Again, you don't have to go this far for this problem, but there will be problems that just say, what are the solutions? And you will have to do all this. And I think this is what you were talking about, Justin. Now you can divide everything by 2. And that would become negative 2 plus or minus 1i radical 2 over negative 2. Is that what you said?
Yeah.
Yep, that's right then.
Where'd you get the 2 at?
Which one? The one under the radical or all the other ones?
Oh, the other
Okay,
one.
I'm completely.
Okay. Well, hold on. 1 second. Corey, were you completely lost on this page?
Yeah, that's when I started to. Then the rest of it was just like, boom.
Do you get where this step comes from?
Yeah, I get it.
Do you get where this comes from?
No.
Okay, all we did was take this step and calculate everything. 16 minus 24,
So
negative
basically
8.
reduce it.
Yeah, we just simplified it.
Where'd you
Then-
get 16 at?
Hey,
B squared, 4 squared, I just skipped a step.
I didn't know.
Oh.
Yeah. All right, which took us to here. Now, like I said a second ago, Corey, since you said you were confused, make sure we listen to this. If you know the roots are imaginary, technically that's all you need for today. But if the question were to have just said, what are the roots, you'll actually have to calculate them. So we had to reduce this as much as we could. First of all, you know how it was negative 8 just a second ago? The negative 8 comes out as an I, and then you could rewrite the square root of 8 as the square root of 4 times the square root of 2, because 4 times 2 is 8. The square root of 4 is 2, which is where that came from. So it became negative 4 plus or minus 2i radical 2 over negative 4. And then, is there a number that all three of these go into? Yes, 2. So we divide all three by 2, and it became this. That is the exact answer for those roots. Not that you needed the exact answer for today, but you will, and since we've already done it, I know I won't be going back to it, so that's a free review. You're welcome. Okay, so anyway, back to our graph. Oop. Oh, no, I didn't just do that. Yes, I did. Oh, well, not a big deal. We remember. Let's see, it was imaginary. Wasn't it 1, negative 1?
Yeah. It was
Down, down.
Let's say I am
negative 3.
Imaginary, yeah. You should already have that down. Negative 3. All right, we're ready to graph. I always start with the vertex. I think that's the easiest spot to start with. The vertex was 1, negative 1. The y-intercept was negative 3. It's not going to cross the axis, which we kind of already could have seen. If the vertex is here and it goes down, there's no way it could have crossed the axis. It's going to have to just go down like that. And we're ready to graph it. That's all we really have. There you go. And if you graph that on your calculator, it should look very, very similar to that. That is what you have to do. You need to find these things, plot all of them that you can, and graph. 4, 2, 4, and 6. Tomorrow, we are going to be finishing up. We're going to be finishing up this topic, just tying up some loose ends. And tomorrow's really not bad. It's a lot of more obvious stuff. And then Wednesday, we're going to re-quiz over all this stuff, and there will not be a quiz Friday. All right, get to work.